That's the idea. Cut off the voltage. You know what I mean? And inside each control box is a battery, because the thing with these machines is you need to start it.
Yeah.
Once as it gets up and running, then it very quickly generates enough juice to run itself. But until it's up and running and able to produce electricity to power itself, it's got to get juice from somewhere else. I thought of and designed a simple wind-up mechanism, as a matter of fact.
Oh, okay.
That you could just put a winder handle on the top of the machine and, you know, just wind it up and it'll kick off. But it's much simpler and less caveman-like to just stick a battery in the control box and then run it from the battery. When it kicks up to speed, you have a very simple circuit. When it reaches enough to power itself, then it just switches over to that form of powering itself. I'm not a circuit man myself, so I don't know how to design those kind of things. But I do know that it's schoolboy stuff for a circuit man. And there's no tall order here, and this is all very, very basic science.
How's energy fed out of the machine then?
From the coils, just 2 wires out.
So you'd have a wire and that would just go into control box.
Yeah,
and
it'll
be
just
split.
go into the control box where it splits what the machine's using and the rest is out. Now what I'm going to do quickly is go through my next ideas that are just a concept on a piece of paper, and then we'll get to the last bit, which is my most interesting story. And again, it's not like all technically complicated, it's more or less just of a basic, this is how it all began and this is what happened and how come I ended up here where I am now. Alright, so moving forward, push pulse generator is a very simple idea where you have a single central axle here with coil arrangements around, and in the middle of the central thing you have these little axles that stick out with a natural magnet on, positive facing one direction, negative facing the other direction. So that would like spin around, one axle spinning in one direction. Yeah, you can see the way I've drawn this is kind of like an adaptation of my existing design, because that's just the way that it was simple for me to do it. Yeah, now that you've seen my other design, this makes more sense as well. And then
See, I'm just thinking electromagnetic charge is using it to push and spin.
So then what you have is 2 fixed electromagnets mounted on the outside, like this, fixed inside the machine. And then as one of these goes past there, it hits a switch which fires that on. And what that does is it makes an electronic field, and these 2 repel each other because they are the same polarity. You see, so you make it fire it so that side is the same polarity as that side, and it repels it. Meanwhile this, because again you've got the 3x2, this hits by that. Just enough of a little push makes it reach here, you see. That one goes, pushes this again, 1, 2, 1, 2, round and round you go. This is just a different way of driving a core containing magnets around and around inside an arrangement.
It's a very similar principle,
coils.
that one.
Yeah.
Am I right in thinking
Yes,
that's in the
it is.
first one?
Absolutely.
Very similar principle.
Absolutely.
3-2 to, like you say, a magnetic push and charge.
So essentially that's all you've got here. There's a bunch of fixed coils around a central rotating arrangement of magnets that generate electricity. And you've got 3 passive magnets on a core axle that rotate the axle. When they pass by the active magnets on the side, a switch fires them, and the polarity on the facing sides of the active and passive magnets are the same, causing the rotating passive magnets to push away, thus driving the machine.
Yeah, no,
Just exactly as I
that.
explained. Right, next one. This one's a shuttle bounce generator, because the way it operates is similar to one of those weaving machines with a shuttle that go left and right, to and fro.
Right, okay.
And this idea is an adaptation of the concept that I've just showed you.
Yeah.
You've got long rods of coils. This is like the front section, and this is like side section, chopped. Yeah, so you have a tube with a magnet in it, and then at the ends of the tubes you've got an electromagnet and an electromagnet, and then arranged around the outside of the tube are just long coils, and then you shoot this magnet inside this tube up and down.
So it's just going back and forth?
Yes, backwards.
But it
up.
can't touch the side because of the charge?
It doesn't matter, because the material you choose for the tube won't conduct electricity, and it won't block magnetism.
So it's just going like that?
Yeah,
against 2 invisible magnetic fields bouncing off each other?
Yeah, so when it comes up to this side, there's a little switch there, you see, and it hits the switch which fires that magnet on, and it makes the polarity the same as the polarity of that side of the facing magnet.
What's the switch then? What's the switch made of?
It's just a switch on-off.
Right, yeah.
So on-off switch goes past, switches on, electricity feeds through to the electromagnet, yeah? And then because the polarity on the two facing sides are the same, they repel each other. The repulsion of magnets is as violent as their attraction, easily. And it pushes it away, back down to the other side of the tube, hits the other switch. What you should really do for a design like this is put a little spring on the end, and a little spring on the end that just absorbs just a little bit of the extra at the end. You see, and gives it maybe just a little bit of a push back. But even just the pure magnetic repulsion is enough, and it just shoots that up and down, up and down. Then when you've got a shooting magnet shooting to and fro in arrangements of coils, makes electricity. This one, as you guessed, is a bit different. This one doesn't work using electromagnetism. This one is a different idea that uses centrifugal force to produce electricity. So essentially all I've really done here is I've mounted a series of simple motors near the center of a disc around a central axle, and on the top of the axle there's a motor that can spin this whole arrangement around. And you can see here I've put little generators on the bottom as well as on the top. I think the way I wrote it is probably better. The series of motors are arranged around a central axle, which is driven by a stepper motor at the top and held by a bearing at the bottom. The small generators have a return spring and string wound around a little axle, because that's a little motor. Then the string is attached to a little weighted wheel that's in a rail on the disc. The idea is you spin this whole arrangement around fast and slow, fast and slow. And then when it goes fast, the centrifugal pulls those weighted wheels out, and when it pulls those wheels away from there, it pulls the string out, which unwinds and winds the axle of the little motor.
Yeah, I
You see, and then when it slows down, there's a return spring on that little axle that pulls the string back in. And then these wheels will generate a little bit of juice out of each of these little generators. You join that all together and it produces more juice. Simple idea. But again, it's a non-electromagnet.
It's not quite as cool as magnets, to be honest.
No, and it's not as effective either.
No. And there's much more that can go wrong, isn't there?
Yeah,
but still,
sure,
better than
but
nothing.
think about it. The size of that stepper motor that's running, that can spin this whole arrangement, only needs to be approximately the size of 2 of these little generators. And if you've got 12 generators, then you're producing 6 times more. Moving on. Friction ball. Again, it's a simple idea using friction to generate electricity, because friction can produce impressively large amounts of electricity. It depends on the materials and the mechanisms that you use. My simple idea is a bunch of sequencing electromagnets that switch on one after the other, attracting magnets inside the core to spin it around, and then you have material on the outside and on the inside that interact with each other to create friction electricity. If you think about all the lightning that comes out of the clouds, that is how that is produced, with friction.
Right.
Okay, there's large quantities of it, but it's friction.